You know those super efficient LED lights in your phone, in your home? They're everywhere. But for years, scientists were stuck on a huge mystery about how they even work. A mystery that brought the whole field to a standstill.
And I'm not exaggerating here. We're talking about experts literally shouting at each other during conferences. And what was all the fuss about? It was a debate over tiny, tiny structures, thousands of times smaller than a single human hair. So to get to the bottom of this scientific whodunit, we're diving into an explainer based on Under the Microscope, the flagship podcast from the Science Talk. Our guide through this whole thing is Professor Rachel Oliver from Cambridge University, who found herself smack dab in the middle of this nanoscience storm. Okay, so what was this mystery all about? Well, it really boiled down to two completely different, totally opposing ideas. You had two camps, and they were not backing down. One side was convinced that these tiny clumps of an element called indium were the absolute key to making LEDs so bright. But the other side? They said, nope, those clumps are just an illusion. They thought it was just damage being caused by the very microscope scientists were using to look at them. Now, how do you settle a debate like that? You can't just get a bigger microscope, right? Especially if the microscope itself might be the problem. Nah, you need something totally new, a real game changer.
And that game changer is called atom probe tomography, or APT for short. And get this. This thing doesn't just snap a picture. It builds a perfect 3D map of a material by mapping out every single atom.
So, here's how this magic works. You take your sample and you shape it into this incredibly sharp needle. Then, a laser zaps it, knocking off one atom at a time. A detector catches it, figures out what it is and where it came from. You do that millions of times and boom, you've built a complete atomic map from the ground up.
All right, so Professor Oliver and her team have the perfect tool for the job. They get their LED material ready, they stick it in the atom probe, and they press go on what they hope will be the experiment to end all experiments.
And the results come in. The APT map, it shows the atoms are just random. No clumps at all. Case closed, right? Wrong. The critics just fired back, saying the new machine probably wasn't even good enough to see the clumps in the first place. So the team needed a smoking gun, something undeniable.
And what they did next was just brilliant. They took a new sample, and this time they deliberately damaged it with one of the old electron microscopes. Then they put that sample into the atom probe. And what did they find? Clumps. Clear as day. This was the proof. It showed the atom probe could absolutely find clumps if they were actually there. The mystery was solved. The clumps were just an artifact of the old tech.
So, just like that, the shouting stopped.
The controversy was finally over. But the ripples from this one experiment, they were just getting started. I mean, this discovery was huge. Not only did it settle a major scientific fight, but it also proved that atom probe tomography was a seriously powerful tool, especially for these tricky materials. It basically opened the door for a whole new wave of research in all kinds of different fields. So one mystery gets solved. But you know how science works, right? As Professor Oliver herself points out, solving one puzzle just reveals another, even more exciting one. Now that we know those clumps were just an illusion, it raises a wild new question. What if we could learn to build them on purpose? Could we actually engineer these structures at the nanoscale and unlock a whole new generation of amazing materials?